Okay, I was trying to get this last one done before the time ran out, but it didn't work. So I may as well go back and do it right and careful. So it says it's a baseball that's 3.35 kilograms and it's traveling towards the batter, right? So it's coming in here towards you. So here you are, and initially the baseball is coming this way, and then of course you're going to hit it and it's going in the opposite direction. So you have to call one way positive and one way negative. On its way in, it's going 46 meters per second. On its way out, it's going 62. Doesn't really matter which one you call positive and which one you call negative. You just need to remember so when you get your answer, you'll know which way it means. So I'm going to call on its way out negative. And so when I do that, then final goes in as negative 62 meters per second. And initial goes in, it's minus, because it's always, remember, delta V is VF minus VI, right? So the negative on the 62 is because it's going in the opposite direction, and this minus is from the equation, and 46 goes in as a positive. So that in the bracket, you have 0.35 kilograms, and in the bracket, you end up with negative 108 meters per second squared. And when you multiply those, you get a negative 37.8 kilogram meters per second, where the negative means like away from the batter, because that's the way that I called negative. Had I called coming in negative, then my 62 would have gone in as positive, and my 46 here would have gone in as a negative, and it would have been a minus, which would have made it a positive, and I would have had in the brackets positive 108, which would have given me positive 37.8, and then I would have said, oh, positive is going away, so it'd still be away from the batter. Okay? So there's some of your samples with those little equations. I'm going to give you a few more tonight just to make sure you got them. But we're going to start today conservation of momentum, which is really kind of cool, and you'll like it too.